My name is Derek Vaughan. I'm an applications engineer at Avago Technologies. Today's data centers are going through architecture changes that are requiring faster interconnects, and this is driving the need for new cables. Server interconnects are commonly requiring 10 gigabit links. These interconnects are typically from port to port within a rack, but often between ports several racks away. The migration towards converged enhanced Ethernet data centers is requiring faster interconnects that have lower bit error rates, lower latency, and fewer drop packets to meet the needs of storage networks. We can see the use of heavy copper cabling in this data center. Copper solutions are thick, heavy, difficult to manage, and have limited reach at the higher data rates demanded in today's data centers. In order to keep up with the demands of future data centers, IT managers require a superior solution with the ability to handle expansion in the future. Avago Technologies is introducing a new SFP Plus active optical cable. These short-reach interconnects offer a cost-effective solution for 10 gigabit per second links at lengths of up to 20 meters. Active copper cables address some of the limitations that we've seen with passive copper cables, but they are considerably more expensive and consume almost twice as much power as Avago's SFP Plus AOCs. Avago's SFP Plus active optical cables offer an alternate solution to passive and active copper cables. Their value proposition is increased link lengths up to 20 meters, lower weight and size, higher performance with bit error rates down to 10 to the minus 15. They're less expensive to install, and they reduce the host board complexity by eliminating the need for CDR and EDC chips. They also consume much less drive power, and an added benefit is that there is a simplified inventory management because now one single part number can address all of the SFP Plus link requirements. So now let's go into the lab and see how these Avago SFP Plus AOCs perform.
Hi, my name is Christopher Wong, and I'm a Senior Applications Engineer here with Avago Technologies in San Jose, California. Today we're going to take a look at a demonstration between the Avago Technologies active optical cable and a passive copper cable. Essentially what we have here is a test board developed by our ASICs product division with Avago Technologies. Essentially it's a test chip. We're going to use it as a pattern generator to run a PRBS 15 pattern at 10.3125 gigabits per second. It's electrically connected to an SFP Plus evaluation board where we'll have our TX side of the active optical cable as the device under test or the copper cable as the device under test. A second evaluation board, an SFP Plus evaluation board, will be used as the receiver. And from there we'll actually connect electrically to take a look at the optical eye, both jitter measurements and mask margin using an Agilent DCA. And now I'm going to be using this copper cable. It's a 5-meter passive copper cable as my device under test. And all I'm doing is connecting up the TX side of this evaluation board with the RX side of this evaluation board. And then we'll take a look at the electrical output. As you can see, the DCA could barely lock onto it, so this copper cable actually needs some serious help. So right now I went over to the ASIC card, and for the TX side I'm going to bump up the de-emphasis to maximum. And we're actually able to recover an eye now. The DCA is able to lock onto that signal. So that's what we're taking a look at, the DCA right here. The mask that we're using is the IEEE 802.3BA, the 10 gigabit Ethernet mask. As you can see at this test point number 4 using the copper cable, the signal isn't good enough. There's many mask violations and it's simply not up to par. This is the Avago Technologies active optical cable. This is a 20-meter active optical cable. So right now we're taking a look at the output of a 20-meter active optical cable. As you can see here, we're taking a look at a total jitter of about 42 picoseconds. It's essentially much longer than what we're looking at with the copper cables at 3 meters and 5 meters. Okay, so this is taking a look at the mask margin with the 20-meter Avago Technologies SFP Plus active optical cable. As you can see right now, it's passing the 10 gigabit Ethernet mask. And as you can see, when we compared it to the copper cable obviously failed, and the mask margin was actually negative 27%. So what we have here is 5 meters of the passive copper cable. It's measuring in at 230 grams. This is a 5-meter active optical cable, so essentially the same length equivalent. And it's measuring in at 75 grams. So you can see in terms of the same 5-meter distance, the active optical cable is much, much lighter. Now with copper cables, they're actually rated at a bit error rate of 1E-12. The Avago Technologies active optical cable is rated at a bit error rate of 1E-15. Now 1E-12 is essentially one error every 100 seconds, so less than 2 minutes. When you're talking about a bit error rate of 1E-15, suddenly you're talking about 100,000 seconds, which is essentially over 27 hours. So which one would you prefer?
The advantages of SFP Plus AOCs are greater performance, reduced power consumption, lower weight and size, and a reduction in overall system costs. Avago's AOCs are the best solution for data centers of the future.